Okay, today we'll discuss about writing a SPI driver for the LPC 769, and in that case I want to show you the two files involved. One is a header file in which I have defined the ports, since there are two SSP ports, SSP0 and SSP1, and therefore I have written an enumerator for those. And there are list of peripherals. These peripherals are the peripherals of the LPC 768. Those include timer 0, timer 1, UART 0, UART 1, and then I2C, SPI, real-time clock, SSP, ADC, CAN bus, CAN bus 2, general purpose input output, I2C, you can see timer 2, timer 3, SSP 0, GPDMA, Ethernet, USB, and everything. Okay, so for this class, we will be doing SSP. So we have two functions. One is init SSP, which initializes the SSP port for transactions, for sending and receiving of the data. The SSP port initialization is based on setting different registers to different values, and therefore we need to give a port number here, and this will set up the port and return a value, either it succeeded in initializing the port or not. Okay, and there's another thing called SPI exchange byte function, in which you give a port number and give a out character, and I mean a byte of data, and it returns a byte of data as well. So it is like exchange byte, so you send the character and you receive a character at the same time. And there are two functions, device power on and device power off, in which you can power on, power off all these peripherals included. So for this purpose we need to power on the SSP0. So let us see in the SSP program. In SSP0 we have included SSP.h. In the init SSP we have passed an argument called ports, and if the port is 0, we will turn on the PC SSP0. In case of it is 1, we turn on SSP1. So what we are doing is we are clearing the clock bits and then setting SCK pin select functionality, setting bit 30 to 1, setting select MISO and MOSI pin select functionality, because since in ARM processor in LPC 716.8 you have each pin have different function, and you can configure each pin to output different, to function as a different pin. Sometime you may use it as a general purpose input output, and sometime you can use it as some other functionality. So in this case you need to pin select the MISO and MOSI functions. So for that you need to write this data to the pin cell 1 register, and after that you set the SSP0 CR0 register for 8-bit mode. You have to write 111, that is for 8-bit mode. LPC SSP0 CR1 register is configured as to configure this as a master, and the speed is divided by 8 up that of the CPU. So if your LPC 760 is running 72 or say 64 megahertz, then you will be running your SSP0 in 80 megahertz speed. So for the case 1 is also the similar thing. This is just for another SSP. So after, if initialization is succeed, then it will return 1, otherwise it will return 0. So you can then compare if the function has initialized properly or not. So the another code function is SPI exchange byte, in which you give the code, and then you give the a byte as output, and you receive something and written in as input. So if port is 0, we will write the byte to output in the DR data register of the SSP0, and we'll wait until the SSP is busy. Whenever the SSP is uh, when the CPU will then uh, exchange the, the the data in the data register. It will send the data and receive the data and put it in the data register, so we can return the data register. So similar here, and if if we couldn't extend the data, then we can return null, so that either we can check it for null and then find the error. So this much for today. Thank you for joining the live. Thank you.